All right, class, we're still in chapter 3, section 3, and I just want to take a quick second to talk about diatomic molecules a little more in depth. So diatomic molecules, they are special in our world because they don't act like all the other atoms out there. When I look at an atom like carbon on here, and when I look at an atom like carbon, I can observe in the natural world that carbon as an atom can be independent and can exist by himself. Carbon and all these other atoms are okay existing by themselves. But there are 7, I call them troublemakers, or there are 7 of these special elements that do not like to exist by themselves. Think of it this way. If I have a chunk, or if I have a certain amount of any element, I'm not going to have just one atom present in that element. I'm going to have billions upon billions of atoms present in whatever I have. So let's say I have a chunk of carbon. That chunk of carbon is going to have all these little individual carbon atoms. But let's say I have a chunk of hydrogen or oxygen or nitrogen or fluorine. These atoms are so unstable by themselves, or they're so desired to break bonds, that they will actually bond with themselves. And so hydrogen, oxygen, nitrogen, fluorine, chlorine, bromine, iodine will never exist as purely just an I or just a Br or just a Cl. Oxygen will not just exist by himself as an independent singular atom, but he will bond with himself. And because oxygen is always present in larger quantities, you can never just have one oxygen by itself. There's going to be billions upon them, so they'll always turn and form a bond with each of themselves, and you'll always have O2. Just like hydrogen. Hydrogen will never exist by himself. He will find another hydrogen, and he will bond with them, and so hydrogen will always exist as H2. And so carbon, it can exist by itself, but all these other guys cannot. How that affects our conversion problems is that we look at our box, and we see that O2, the diatomic O2, actually has a molar mass of 32 grams. N2 has a molar mass of 28.0 grams. H2 has a molar mass of 2 grams, where helium has a mass of 4 grams. What we recognize here is because there is 2 hydrogen and 2 nitrogen and 2 oxygen, I have to double the masses from my periodic table. On your periodic table, it would tell you 16 grams equals 1 mole of oxygen. That's not true. Oxygen never exists by itself in the real world. So whenever you have oxygen, nitrogen, fluorine, or the other diatomics, they will have to double their molar mass. And so when you do your conversion problems, make sure you double the mass of your diatomics to get the right number. Another way to remember the diatomics is they form a 7 on your periodic table. So you can see a 7 and they form down. So N to F, and then they go all the way down. N to F. And we just throw in hydrogen. I hope this helps. We'll have tons of practice. Good luck.